Okay, today we are going to talk about chemical bonds. And the first, I want to ask you a question. Why some atoms are stable and others are not stable? And let me give you an example. Let's take a look at the structure of neon atom. It's one of the noble gases. Noble gases exist as single atoms. And you can see here there is a picture which shows us electron formula of neon atom, and we can write it in this way, like you already familiar with. So neon, its number in periodic table is 10. That means that it has 10 protons in its nucleus, and has 10 electrons in outside of its nucleus. So it's element from period number 2. That means it has two shells. So the first shell, and this is how many electrons have this first shell, have only 2 s electron. That means one s2. And the second shell, we can see it's completed. um, it has 2 electrons on second s subshell and 6p electrons on second p subshell, and together they give us 8 electron on its outer shell. So, and we can see 8 electrons. So outer shell is completed. Please remember, when last shell or outer shell is completed, atom is stable. Examples are noble gases. So noble gases: 1, 2, number 2, 10, then argon, number 18, then krypton, number 36, then xenon, number 54, then radon, number 86, and they have 8 electrons on their outer shell, except helium. It has only 2 electrons at all. That means that its outer shell completed when it has only 2 electrons. So now you might the first meet octet rules. Octet rule. What does mean octet rule? Octet rule means that stable atom must have completed outer shell. 4 elements from period second, third, and so on, completed outer shell has 8 electrons. Exactly octet rule. But from element from period number 1, it's hydrogen number 1 and helium number 2. They're stable when they have 2 electrons on their outer shell. So let me give you another example. Fluorine. Fluorine has number 9, and its element from second period 2, but it has 1 electron less than neon. And we can see that there is no there is not 8 electrons on its outer shell. It's only 7 electrons. But it has to be 8 to be stable, right? So what prediction we can tell? Fluorine, if it does not have 8 electrons, it must be unstable. Yes, it is unstable, and that means that fluorine gas exists only, not in atoms, only in diatomic molecules. So atoms are not stable. And let's go back to noble gas, neon. Atoms are stable, and noble gases exist as single atoms. So atoms have a tendency to have 8 electrons in their outer shell. Octet rule or duet rule means that 8 or 2 electrons must be on an outer shell to make atom stable. So atoms, to become more stable, atoms can join together by forming a chemical bond, which is a very strong attraction between two atoms. Chemical bonds are formed when electrons are in different atoms interact with each other to make an arrangement that is more stable than when the atoms are apart. So neon, argon, helium, just single atoms. They're stable. But fluorine exists as a diatomic molecules like fluorine F2, exactly like hydrogen. Hydrogen has only one electron on its outer shell, and it exists in diatomic molecules too. So H2. The same as oxygen, O2, the same as nitrogen, N2. And this is a great example that atoms can join together by forming a chemical bond, and this chemical bond formation makes molecules more stable than single atoms. So there are different types of chemical bonds exist around us. So we are going to talk only about, not only, today we're going to talk about ionic chemical bond, but there are others. So covalent chemical bonds, it can be non-polar or polar, and we're going to talk about these type of bond next time. Ionic bond we will be talking about today, and metallic bond. So we just will tell some few words. That's all. So ionic bond. This is the matter of our class today. So ionic bond. For example, ionic bond, it's easier way to predict is there ionic bond or covalent bond. If we see compound which has metal and non-metal, at the one compound, there high possibility that this is ionic bond between them. So great example is sodium chloride. You know them. You know this compound as a table salt. So sodium chloride, table salt, and two atoms, sodium and chloride, um, attracted and bonds with each other by ionic bond. So, how ionic bond is formed? You can see here there is a picture which shows us uh, electron configuration of sodium and chloride. And you can see here the red 0, that means that sodium and chloride here atoms, because atoms are neutral, right? Neutral, right? So sodium plus 11 means that it has nucleus, and charge of its nucleus is 11, right? Plus 11, positively charged nucleus. And 2 plus 8 plus 1 gives us 11 electrons. So yes, sodium has 11 protons in its nucleus and 11 electrons outside the nucleus. And atom is neutral, okay? So chlorine. Atomic number of chlorine is 17. That means that it has 17 protons in its nucleus and 17 electrons outside the nucleus. So plus 17 charge of its nucleus and 17 electrons charged minus 17, and it gives us 0. So chlorine is an atom, neutral too. But we cannot see 8 electrons, right? We see that sodium has on its outer shell only 1 electron. See? And chlorine on its outer shell has 7 electrons. They are unstable. What is the way to become stable for sodium? There are two ways, I guess, or sodium can gain 7 more electrons, right? Or it can give away this one from its outer shell. And you can see that second shell is completed. It has 8 electrons. And easiest way for sodium to become more stable gives away its one electron from its outer shell. And its electron goes to chlorine, because chlorine is that kind of atom that needs very much this one electron. Why? Because it has 7 on its outer shell, and to become stable it needs 8, right? So, and one electron from sodium goes to chlorine, and what happen after that? So sodium loses its electron. Now it has 11 protons and only 10 electrons, right? The charge of 11 protons is plus 11, and the charge of 10 electrons is minus 10. And together, if we add one to another, we will get plus 1. That means that now it's not an atom, because we know atoms are neutral. And this particle has charge sodium plus 1, or just plus. And now it is not an atom, it is an ion. Ion, a particle which is formed out of atom by gaining or losing electrons. Okay? So if its charge positive, that is cation. Cation. So I would name this particle sodium cation. Okay? And what happened with chloride? Now it's not neutral too because its nucleus still has 17 protons, and the charge of 17 protons is plus 17, correct? And because chlorine gained one electron from sodium, right now it has 11 or 18, I'm sorry, 18 electrons, right? And the charge of 18 electrons is minus 18. And the total charge of this particle will be minus 1, right? So now this particle is not an atom too, it's an ion, an ion, anion. It's negatively charged particle which is formed from atom by gaining electrons, okay? So atoms become more stable when they are ions, okay? So, and just please take notes that positively charged ion is cation and negatively charged ion is anion. And compound which is formed here, NaCl or sodium chloride, this is ionic compound. Why it's ionic? Because it has ions, right? Sodium ion and chloride ion, and attraction between these ions is ionic bond. Okay? So this picture shows us in a different way what is happening with sodium atom when it becomes sodium cation, or with chlorine atom when it becomes chloride anion, right? So you can count these dots. Sodium atom has 11 protons in its small nucleus and 11 electrons outside the nucleus. So zero overall charge. Atoms are neutral. And this is cation. Why? Because it has more protons than electrons. That's why it has positive charge. And the same with chlorine. When it's atom, we name it chlorine, and it has no charge, it's neutral. When it becomes an ion, we can see electrons, the number of electrons. Now it's more than number of protons. That's why it's negatively charged. Okay, and chlorine, and you can see and here chloride. We change this ending, right? So INE changing for IDE. When it's negatively charged ion, we name it in a different way, not chlorine, because chlorine is atom, neutral atom, and chloride is an ion, negatively charged particle. So, ionic bond. Ions having opposite charges attract each other. So this attraction is called ionic bonding, and the compounds formed by this way are called ionic compounds. So, table salt, again, sodium atom was neutral, chlorine atom was neutral too. After they become ions, opposite charged, and now they attract to each other, and between them ionic bond formed. So this is a picture which shows us actually how they are located in a table salt. So, and you can see they how to say, they changing. So we have negatively charged ion, then positively, then negatively, positively, and so on. Why it can't be like positive, positive, positive together, or negative, negative, negative together? It cannot be, because only opposite charged ions attract to each other. But the same charged ions, they cannot stay together. Okay? Please remember that. So, you need to predict what is the charge, what will be the charge of ions. So, periodic table will help us with that too. So, if we are talking about positively charged ions, cations, so usually they charge their charge exactly like the number of the group where its atom is located, like 1A group, and all these elements tend to form cations with charge +1. 2A elements tend to form ions with charge 2 plus, and 3A 3 plus. Okay, it's easy to remember. So for metals, it's usually equal to the group number. For non-metals, there is a way to remember it too. So we need to do this calculation. Negative charge will be equal number of group minus 8, and we will have negatively charged, the charge of negative ion. So let's check. For elements from group number 7A, like fluorine, chlorine, bromine, and iodine, their stable negatively charged anions will be have -1 charge. Okay, for group number 6A, stable charge will be 2 negative. For 5A, 3 negative. Because let's say for 6A, number of groups 6, so 6 minus 8, I'm sorry, I was speaking in Russian, minus 8 equals 2 negative. Okay, and we see these 2 negative here. And in chapter 3, there is a table which will help you to to get the information about common charges for elements. So just pay attention to this. And we already talked about 1A, 2A, and from group from 3A to 7A, it's kind of easy, right? But for transitional elements, there is a rule that they can have different charge. Let's say iron. For iron, it's common to have a 2 positive or a 3 positive charge. For cobalt, 2. So 2 positive and 3 positive charge. So just pay attention to this table. So let's write electron configuration for atoms and for iron. So fluorine. Let's go back. Fluorine, its atomic number is 9, group number 7A. That means that it has 9 electrons. Period number 2, so it has 2 shells. So and for atom, which is neutral, it will be fair to write this electron formula: 1s2, 2s2, and 2p5, and 7 valence electrons. You can see here. And for anion, when it's negatively charged, so negatively charged 9 still, that means the number of protons will be the same, but the number of electrons will be different. So one electron will be gained. So 1s2, 2s2, 2p6, and you can see octet rule. This fluoride anion will have 8 electrons on its outer shell. So for sulfur, its atomic number is 16. Let me check in periodic table. So yes, 16. And period number 3, that means that electron configuration will be 1s2, 2s2, 2p6, and 3s2 and 3p4. So 6 valence electron. Atom is neutral, but when it becomes anion, so let's take a look. Group number 6A. That means that when it becomes more stable, negatively charged ion, its charge will be 2 negative. So 2 negative means 1 electrons more. So, and 2 more electrons gain sulfur gain on its outer shell. So it will be 1s2, 2s2, 2p6, 3s2, and 3p6. And we can see again 8 electrons here and 8 electrons here. And let's do another one. So nitrogen, number 7. Period number 2, 7 electrons. For neutral atom, it will be 1s2, 2s2, 2p3, 5 valence electrons. When it becomes anion, its charge 3 negative, so 3 more electrons, 7, 3 negative here, 1s2, 2s2, and 2p6, 8 electrons. And you can see, so fluorine, when it gain 1 electron, it becomes as a neon, its electron configuration like neon has, right? So I can see Now I can write like this. For sulfide anion, it will be a configuration like another noble gas have argon, right? And for nitrogen, it will be the same like neon too, right? For these anion. So, and you can do this by yourself for chlorine and oxygen. And what's about metals? Metals do not gain electrons. They lose electrons. This is easiest way for them to become more stable. So we already discussed about sodium, but let's do the same with potassium. So it's number 19 and aluminum. Let's do two of them. So potassium number 19, period number 4, that means 4 shells will have electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. And you can see group number 1a, right? 1a for potassium. Positive charge will be 1 positive and 1 valence electron. When it becomes cation, it loses its outer shell electron, so and its electron configuration will be like argon has. So 1s2, 2s2, 2p6, 3s2, 3p6, and I can write down like argon, okay? For aluminum, aluminum has 13 electrons because its atomic number is 13. So, and electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p1. So 3 valence electrons here, and to become more stable, it needs to lose these 3 outer shell electrons. So, and its electron configuration for this cation will be 1s2, 2s2, 2p6, like neon has, a noble gas. And for magnesium and calcium, you can write by yourself electron configuration.